Okay, great. Let's continue by introducing the concept of an estimator of a population parameter. It is an approximation depending solely on sample information. A specific value is called an estimate. There are two types of estimates: point estimates and confidence interval estimates. A point estimate is a single number, while a confidence interval, naturally, is an interval. The two are closely related. In fact, the point estimate is located exactly in the middle of the confidence interval. However, confidence intervals provide much more information and are preferred when making inferences. Don't worry, we will have a separate lesson dedicated to confidence intervals. All right. Have we seen estimates so far? Sure we have. The sample mean x bar is a point estimate of the population mean mu. Moreover, the sample variance s squared was an estimate of the population variance, sigma squared. There may be many estimators for the same variable. However, they all have two properties: bias and efficiency. We will not prove them as the mathematics associated is really out of the scope of this course. However, you should have an idea about the concepts. Estimators are like judges. We are always looking for the most efficient, unbiased estimators. An unbiased estimator has an expected value equal to the population parameter. Let's think of a biased estimator to explain that point. What if somebody told you that you will find the average height of Americans by taking a sample, finding its mean, and then adding 1 foot to that result? So, the formula is x bar plus 1 foot. Well, I hope you won't trust them. They gave you an estimator, but a biased one. It makes much more sense that the average height of Americans is approximated just by the sample mean, right? We say that the bias of this estimator is 1 foot. Clear? Okay, great. Let's move on to efficiency. The most efficient estimators are the ones with the least variability of outcomes. From the estimates we know so far, we haven't seen estimators with problematic variance, so it is hard to exemplify. It is enough to know that most efficient means the unbiased estimator with the smallest variance. A final note worth making is about the difference between estimators and statistics. The word statistic is the broader term. A point estimate is a statistic. All right, this is how we can describe estimators and point estimates. In the next lecture, we will explore confidence intervals, so stick around.